I know it's the last talk, so I appreciate everybody coming. I threw in some Star Trek memes to kind of like make this a little bit more fun. So as we start talking, and you might ask yourself, okay, why GPU CI? Well, some of the immediate things that start coming up, the proliferation of kind of GPU applications are starting to come out, not only just projects like PyGDF that was been mentioned a couple days ago, and then also Numba as it's starting to use some of the GPU accelerator code. We need to be able to test these types of things. Also at NVIDIA, we're seeing stuff like external demand. So while we're working and collaborating with other partners, they're like, how can we better effectively create this code? Because we got, NVIDIA engineers, 4 other companies that are all contributing to one code base. How are we actually making sure everything works? Because right now, with just kind of like a Travis CI or something that's working, it says, hey, everything's good, when that might not be the case. The other side of it is also kind of this internal demand too. As we're scaling out, tackling these larger problems with GPUs, we see the need for us to be able to do the CI internally so we can actually do some of these more advanced pipelines. And I'll talk a little bit more about that later. And I think the other part that I'm kind of like really wanted to get to is also performance testing. So, as we release new versions of CUDA or drivers or even new hardware, it'd be really great to kind of like automate that process of just being able to say, yeah, the performance is scaling as we expect it to, or if there is a problem, we can kind of catch it a little bit earlier. So there are some challenges when we start thinking about GPU CI. Obviously, you need a GPU. So it's either it's like in the cloud or physically there. Resource management can be a problem where you're trying to make sure that you don't want somebody to kind of submit a job, take over the entire thing, stall out everything else. You also want to be able to expose all the configurations to the developers. So when the developers are submitting their projects and they have certain requirements for driver configs, CUDA versions, or even a specific driver that they need, you want to be able to kind of make that available so their builds aren't breaking. There's also different libraries and methods. So there's a lot of pieces where we're wanting to integrate GPU-specific tools that might do like memory check or something like that into the CI that don't actually exist right now, or at least have that in the pipeline so I can do that particular testing as I'm running. So if I do have an error, I can easily more troubleshoot where that actually happened. Travis CI, Circle CI, and others don't necessarily support GPUs, and since they are mostly cloud-based, it's probably for good reason, because I could imagine just submitting like a little job that starts mining, and then it might constantly fail, but if it keeps going and runs for that, like whatever that timeout is, I can get those pennies into that pocket. For the tools that offer native support, so Jenkins CI, and GitLab CI definitely have some stuff. It's still very hacky. I'll talk a little bit more about that as well. So how do we kind of like implement GPU CI? We can kind of get the second command, check the chief engineer, head of security, and Dave the new guy, and hopefully they'll be able to figure it out. Easiest ways to start is bare metal and GPU. So I mean, there's some benefits to that, but there's also some challenges. The first is you really reduce the complexity when you're trying to do anything, because it's just as long as you have an operating system, you have the drivers installed, and you have your GPU, you're pretty much ready to go. The problem here is it only kind of works for a small subset of projects, and you're kind of limited when you start thinking about like the CUDA version, driver version, and OS pairs for being able to do those testing. And then also, when you're thinking about doing something on bare metal, if you have several projects, dependency management starts becoming pretty. It is manageable with other tools and that kind of stuff, but it can become a headache, especially when you're dealing with Python, as many of you guys know. And of course, resource management is definitely difficult. So what does it kind of like look like from a visual perspective? We've got the server, we've got the GPUs, could be one or more, and then kind of just the CI environment just kind of sits on top. Source code kind of feeds into the tests go to the test results, and it kind of gives you the thumbs up, thumbs down, are we good? And you can either tie that into a pull request or whatever it might be, so the results. So how can we make this better? Right now, one of the things that NVIDIA provides is called the NVIDIA Docker runtime. And what that does is allows, if you have Docker, it's a specific runtime that sits next to Docker that does GPU pass-through. So the drivers and that kind of stuff that you have on your system, you don't have to worry about trying to configure that inside of the containers, but then it also allows you, when you get into the different containers, that you can have the CUDA toolkits, different versions of CUDA. As long as the base version of CUDA is kind of like the highest that there is, you can test with all these different ones. So it allows that ability to kind of do those different pairs of CUDA and operating system testing. You're still limited to whatever the driver version is on the machine, but it does allow you to kind of test with all these different operating systems. As far as like where it works right now, it's on Debian, Ubuntu, Red Hat, CentOS, and Amazon Linux. And it's at that GitHub, which I'll also have the link at the end. But the other important thing here is it does those driver operations and kind of like the resource management and GPU visibility and the kind of things that we need for developers. So if we take this approach, what are kind of the benefits and challenges that we have? One of those is, like I said, those multiple combinations of CUDA and operating systems. It's really easy to do dependency management now because we are operating in containers. Containers are great for that, especially at NVIDIA. Like when we're doing all of our deep learning frameworks that we're using, they're all container-based. Just because if you imagine trying to run PyTorch and TensorFlow on the same system, bare metal, it just would be a nightmare. And like I said, the resource management side definitely makes it a lot easier. And then also the scale is really important. So the only challenges over here are kind of like the hacky side of the nature of it. You either have to have pre-built Docker images for the testing, or you need to kind of like build in that pipeline with your CI, build the Docker container that you want to test in, copy your code in, and do everything else. It tends to be environment variables and kind of cumbersome to manage. And then for GitLab and Jenkins, you need like a runner basically on each node to be able to do this, and then the GPU nodes. So how does this kind of compare to what we were looking at before? So now we have the server with the GPUs, and off to the side is the Docker with the NVIDIA runtime, where now the Docker file or the container that we're starting with in CI basically starts from there, then kicks off this custom config that knows how to run Docker with the NVIDIA runtime plus all of the other configurations that you want to use, goes in, source code kind of gives us the results back with the testing that we have. Test results come out of the container to the CI environment, and then again, get that thumbs up or thumbs down. So, can we do better? Janeway was able to do better, so we should be able to. One of the things is for Jenkins. So this is one of the research projects that I've been working on. It's not open source yet, but I'm working internally to open source it, so I will have a link of where it will be once it is public. But basically, it's trying to make it a lot easier to use the NVIDIA Docker plugin just natively within Jenkins. So it's now UI friendly. Just kind of go in and say, I want to select, I want to use Docker. I want to use this particular runtime. I need this version of CUDA. And then if there's any like these driver settings or any other kinds of restrictions, I can actually go through and just set those without having to worry about all the underlying pieces. Another nice part about this is it does support side containers also with GPU support. So if you do have a project where you need multiple containers that also do need access to GPUs, you can run that. And then again, by having the configurability where you can go to GPU visibility, now you can actually separate that out and say, okay, this container that's maybe running TensorFlow or whatever needs one GPU, and then this other container that might be running Numba to do some ETL or whatever can use this other GPU. So I'm going to do a quick demo of this. So I'm actually going to kick off this build. It takes about like 2 minutes, so while that's running in the background, we can look at the configuration. So this is kind of like what the plugin looks like. You basically get this nice little checkbox that once you check it, you get all these options. Let me just make it a little bigger. You get all these options where you can either build from a Docker image or you can build from a Docker file. And if you're building from the Docker file, that can be inside the repo. And that opens up a lot of more possibilities for developers, which I'll cover in a little bit. Basically, if it's a Docker image, you can just say, this remote repository, pull this image. You can even force pull. And then if it is a Docker file, you can even give a context path. That way, if it's in like a folder somewhere, like you have a testing folder, you can get the information or get the plugin to where the Docker file will be. As far as the advanced settings, as we saw in some of the screenshots, it's going through and being able to say, I don't want to use the standard Docker default to run C runtime. I want to be able to actually use the NVIDIA one, which gives me the GPU support. I could then customize the driver settings. By default, it's the compute and utility. That way you can run commands like NVIDIA SMI, and then NVML, CUDA, all those others. But say you're trying to do graphics or something else, you can add those in. And then there's even the nice area where you can just kind of like do a comma-separated list and specify your own. So the other thing here is like main piece, like I was talking about resource management, is when you're wanting to do visibility. So there's been a lot of requests and that kind of stuff, and I'll talk about kind of some future research that I'm trying to work on of trying to be like, how can we kind of subdivide a GPU a little bit more? Because if I'm doing a test on CI, I might not want to allocate an entire GPU just to make sure my code runs. Not quite there yet, but at least we're thinking about it. But at least here, I can actually be able to target individual GPUs to make sure that not one is being saturated, or I don't run the job by default, which is I see all the GPUs that are on the box, and I'd be able to grab as many as I want. And then as far as like anything else for the job, it's just kind of like a standard Jenkins job. I just kind of point it to my Git repo and tell it I want to build master. And the only commands that I have down here, these three, so I'm building PyGDF, which is the Python GPU data frame that we've been working on for the past year. And, excuse me, it's one of the first external repositories that I'm trying to like kind of make public GPU CI available. And one of the things here is like the 3 lines that I've highlighted are just kind of in the README, where we're doing a Conda environment create, we're activating that environment, and then we're doing the testing. The first 2 I just added for some debugging so you guys can see what's actually happening. So let's go take a look at the job that just ran. So what it's doing at first is it launches a one Docker container, which is kind of the Jenkins slave that then like pipes into the other Docker container that we're building. It pulls down the repo and then notices, hey, there's a Docker file in there. I'm going to build that Docker file. Once the Docker file's built, it'll actually start running it. Since this is built in the previous one, we don't see the whole build path, but now we're doing the environment, so we can see like the things that I had configured in the plugin are actually accessible, where I'm only looking at the second GPU. I can look at driver capabilities, and everything's set. And as I go down, I'm looking at the NVIDIA SMI. I can only see 1 GPU, but if I actually look over here, there's 4 GPUs on the same box. So I'm only actually, even though I'm inside that container, I'm only visibly being able to see 1. And when I do the next demo, we'll be able to see this live. And the meat of all this is to get to the end here, where now we're getting all of these GPU tests that we can't do with Travis CI. 559 of them at the moment in PyGDF, all of them passing and everything giving a thumbs up. So what does it kind of look like now? So we're now doing the Docker file or container. So we're kind of like pointing to a container plus the plugin config. So all of the kind of like overhead of trying to figure out how to run Docker, or even managing the process of I have a base image that I know I want to target and I want to start for my testing environment, and then trying to get your code, the latest version of your code in there, and your tests and all that kind of stuff, all that's abstracted. So now it's just you, with the plugin, you just kind of like point, you say I want to start here, it takes care of copying your code in there and then running any commands necessary inside the container. So it has the path of source code, the test, and the results come back. So definitely much more simplified. So how can we save the DevOps and empower the devs? So one of the things is now that we're being able to do stuff like this with the plugins and have like these Docker files and stuff like that, now we can, for these applications, because they change so much and the dependencies change, it's a lot easier to kind of put that control inside the repository. So we can have the Docker file there. We can then have Conda environments. So really, we're just trying to streamline the CI process and control. So when we do try to do like pull requests or we're asking the DevOps team to do something, it's just very simple, like set this up and like target this Docker file in this directory and target this test script in here, and everything else is left up to the developers to then iterate and move forward. And one of the things that we're working on, just because we're in this space and we're trying, and I really want to kind of push this back out, is try to define, what are some of the best practices when doing GPU CI. Not only just because it'll be helpful to us, but also as anyone develops on our ecosystem, if they run into any problems, it'll be easier if there's kind of like a standardized stack that they can come back and talk to us. So like I mentioned, one of the things for Conda environments, this is an example for PyGDF. We kind of have this folder of Conda environments. There's one for building documents, there's one for a notebook, and then there's also one for testing. Each one has a little bit different dependencies necessary, so we use the different configurations for that. For testing, we just kind of pull and activate the testing py3.5. As far as like figuring out what the best practice for this, we want to go from a single environment, test environment on maybe Python 3.5 and CUDA 9, and we wanted to do like CUDA 9.1, Python 2.7, and stuff like that. That research remains to be seen, and I welcome input. So we're getting there yet, but we haven't gotten there yet, but we intend to get there. The next piece is for the Docker file. So this is an example of the Docker file that's in the PyGDF. One of the things here is just at the top, I'm just sourcing from NVIDIA's CUDA 9 devel, which actually the base image off of that is Ubuntu 16.04. And there's also many other versions, so if you need like CUDA 9 on Red Hat or, CentOS, you could do that as well. But the following lines are just like exact copy and paste from the mini Conda 3 install Docker container. So basically what this is just giving me is a environment with CUDA that has a toolkit, so I can do all the GPU stuff that I need. The drivers and everything are passed in by the NVIDIA runtime, so I don't have to worry about that piece, and then sets me up with the base mini Conda that I need to be able to run all my tests and do the Conda environment creates that kind of set up all my dependencies and manage everything for me. And then for us, just to kind of make it a little easier, instead of kind of just like throwing it directly into the root directory, just kind of putting it in a Jenkins CI folder for right now. And so if you think it more advanced, like I kind of mentioned, like if we want to do multiple versions of CUDA, CUDA 8, CUDA 9, 9.1, and all these different testings, you're going to have to start pipelining this. Trying to do everything one by one it's possible, but it's not going to be as good as it could be. So also one of the nice things about pipelining in Jenkins and also GitLab has this functionality in their GitLab.yaml is you can do parallel stages as well. So even though you build out these pipelines to do kind of like the build, the test, and the deploy, you can run all of those in parallel, testing on the multiple versions of CUDA and operating system and that kind of stuff to make sure that everything is green across the board. So now where do we get to? So now it's just, like I said, the really easy plugin config where I'm not really choosing that many options. I'm not really having to really update and change things a lot as on the DevOps side, but on the developer side, I've got my Docker file where I have the tests and information where I need to inside the repo with the source code. So that gets sourced by the plugin, then starts the process with the source code, and then we again get the thumbs up or the thumbs down. So with some of the pull requests and that kind of stuff, I just want to kind of show how easy it is to kind of go from, let's see, let's start over here, make this a little bigger. So this is actually my fork of PyGDF. Like I said, haven't kind of gotten the public GPU CI implementation there yet, hopefully in the next week or so. But one of the branches that I'm working on is this GPU CI branch. This is where it gives me that kind of Jenkins CI folder where I've got the Docker file, I've got that test.sh, where I'm just going to call. It's the same lines that I had in the previous one, just so I can do some of the debugging and stuff like that. Again, using Conda to manage all the dependencies and activate that environment to make it a lot easier to keep things consistent just with what the developers have also on their laptops. So I'm just going to create a pull request and back to myself. And actually, 1 second. I'm just going to have to, since I already have one, I have to ask it to retest this, please. So what this is doing in the background is it's actually, I'm going to like pull this up so everybody can see. Well, first off, I got this bot called GPU Tester. It's going to be able to kind of interact, and that's what Jenkins is using in the background to power its pull request builder. So basically, it's going through here and checking like every minute and going and saying, hey, is there a pull request outstanding? Is there something that I actually need to build? And it's very straightforward and easy to use. So after the minute's up, it'll check. If you're doing this on the public side and you have a public-facing Jenkins instance, it's a lot easier to use webhooks because then it'd be basically instant. Unfortunately, we just had to wait a little bit, and now it's kicking off the build. So if we look on the right side, this is actually the NVIDIA SMI of the station, of the DGX station that's at my house. So I've got 4 GPUs inside of that. And if you look on the right, let me just make this a little smaller again. Or, sorry, your left. On the right is the station, so you can see there's actually 4 physical GPUs there. On the left is actually the output from the test. I've restricted it to GPU 2, and it's only being able to see 1 GPU. So as it's going through, it's going to take a little bit while because it's doing the update for the Conda environment, so we might have to just check back in on a second. But as this starts running, the tests and that kind of stuff, I'll actually see all the activity in NVIDIA SMI on GPU 2 and nowhere else. So let's just check. Basically, how do you kind of like get the pull request builder working? Best thing is to kind of set up the bot user, kind of like I did with GPU Tester. That way you're not using your own credentials because it does need pull request and some access to like PRs so it can do comments and updates to that. And then once you have that bot, you just have to configure the plugin credentials in the system settings. And then for an actual project, it's very easy. It's kind of like these 4 steps. Make sure that the project is a GitHub project with a URL. Set up the Git SCM with the repo URL and the targets. So you could either make sure you're just building master or pull request or both. It depends on how you want to set it up. So whatever works for you guys. And then you just enable the pull request builder. And like I mentioned before, if you're using webhooks, if you're public, definitely use webhooks. It'll be faster. So if we go back, working on PyTZ, almost there. And then for GitLab, since this is kind of all integrated and they have CI, they also have this as well, kind of baked right in. Almost there. So while that keeps running, Kubernetes is really where a lot of this more possibilities and kind of like the features and stuff that we really want. So where are we going with that? Real quick, let's check. Still unpluggy. Okay, so for the benefits and that kind of stuff, as far as Kubernetes version 1.8, they're on 110 now. They're with the NVIDIA Kubernetes plugin, you actually have GPU support. And it takes care of the kind of like that runner thing that I was talking about before, where you have to have these runners that are locally on GitLab and Jenkins to kind of dispatch these jobs. Kubernetes is going to do the resource management and kind of scheduling. The only challenges at the moment right now is you can only target GPUs on homogeneous nodes. So like if you have a node that's got mixed GPUs, it doesn't, right now Kubernetes doesn't understand the difference between that. That will be fixed in future versions. I don't know the ETA on that, unfortunately. And the only other side of this is For the Kubernetes side, not all the Kubernetes plugins on the CI actually support the GPU aspect. There's still some hackery and that kind of stuff. Okay, we're on that. But as far as like Docker containers and that kind of stuff, we can still take some of the similar approaches that we were using before. So just talk about the Kubernetes device plugin. There's a link here, and there'll be one at the end. It allows you to kind of do these resource limits where you're actually saying, I'm requesting 2 GPUs, because if you don't request, or if you don't specify anything, you'll basically, you don't get any GPUs, and then if you target a specific node, like you'll get all of them. So definitely you want to be able to use these. It's the supported way. I put that in quotes because it's still considered to be an alpha version, but we are working with the Kubernetes team to kind of improve this as best as we can. And okay, now really quick, head back. So now we can see like GPU 2 is sitting over there, and we're actually running. We can see that the Conda environments, and we're actually running Python, and all the tests are running. So one of the other things to get this up and running is pretty straightforward as far as if you basically just have a regular Kubernetes install set up. For the GPU nodes, you just need to take a couple extra steps. Besides having Docker installed, make sure that NVIDIA Docker runtime is there. The default Docker runtime has to be changed to the NVIDIA one. That's just because right now there is no way in Kubernetes to kind of also specify, like in this particular YAML, to say, oh, your runner for that container needs to be the NVIDIA one, not the runc one. So it's kind of just the hack at the moment. Also have the device plugins for Kubernetes. The feature gate needs to be enabled. And then there is a YAML config file that's inside of the repo that you just kind of run on that machine or any machine that has GPUs, and it'll set up everything to make sure that when you're doing these limits, it can identify across the cluster and say, okay, this particular node supports GPUs. Now, as far as like targeting particular GPUs and that kind of stuff, if you go to the device plugin site, it'll actually show you where you can do specific naming as far as this particular GPU is a V100 on this machine or a P100 or whatever it might be. So that way, if you do want to do some, not just like CUDA and OS and different types of Python versions, if you want to also mix that with different hardware, you can do that as well. So how does this kind of like all come together? We got the K8 plugin sitting next to kind of like the Docker and NVIDIA runtime over on the Kubernetes worker. We pull the Docker file or container kind of gets put into a container repo. Pull out the custom configuration, so we'll talk a little bit about that, how it's still a little hacky, but we're working on trying to make that better. Send all that over to the Kubernetes master, which kind of finds the spare resources, spins up the Docker container, get all the tests and everything back, and thumbs up, thumbs down, and hopefully thumbs up. So where are we at today on the Jenkins side? So right now you can do kind of limits around CPU and memory, but nothing around GPUs. You can define custom YAML pod templates, and in here, this is where you can actually kind of like paste in what we saw earlier as that test of the CUDA container with CUDA devel, and then also the digits container. So this is kind of like the hack around it to be able to do it today. I'm working on trying to make this better as far as ETA, hopefully in the next couple months. And then GitLab also has similar support in their YAML CI config file to be able to target Kubernetes and do this as well. So like what next, right? CI is solved, everything's done, the world's happy. But really it's going beyond CI, because once we solve CI, now we're opening up all these other possibilities. First off, like I mentioned before, is performance testing. So now it's not just about what you're building, it's also about what your dependent teams or whatever else the businesses might be depending on you for. So now they can be able to test against you, make sure you're not impacting their performance, and vice versa. It also allows the other side of, if you think about it, when you're trying to adopt new libraries and everything else, instead of kind of just throwing things over the wall and hoping for the best, you can look at new GPU drivers, CUDA versions, and Conda packages, and different Conda environments, and do all that testing ahead of time, and then check the output and say, okay, we're doing better, as good, or worse, and then sometimes hold back on a release and not adopt the next one. One of the things that I found out while doing this testing was we didn't actually have a cap on our pandas for PyGGF version, and a new version dropped, and then all of a sudden, like, all my tests were failing, and I'm like, did I break something? And then it was just because we didn't actually like freeze a pandas version, and because they had updated something. So true story, it does, it can help. And then the next side of this is continuous delivery, right? So, I mean, usually CI always comes before CD, right? After the successful build and test, we've got that, and all the developers are happy. Now we want the artifacts and everything else that we produce to be able to be pushed to dev or to prod, and hopefully done in an automatic fashion. And then the last part, which I think is really exciting, is when you think about it from a data science perspective, now you can combine the CD side with the performance side to really extend these best practices for code to models, right? So you want to be able to do like A/B testing with models, review their accuracy before deployment. So kind of like an example of this is how do you kind of like get rid of that costly test and deployment task? So once the new model gets updated, it's just basically treated like code. Pull that into the CI environment. You kind of do the performance tests on it. You've got your sample data, your test data, that kind of stuff. Whatever accuracy comes out of that, you have some kind of decision point, right? You want to say, did this pass, does this fail, as far as comparing it to what is actually in production or into dev. Go to dev, test that more. Maybe it's something where you're testing it over real live data for a day, a week, whatever it might be. And then finally, once the dev testing kind of graduates, you have like another decision point, right? It's where's that performance lies? Are you passing or failing? And then to deploy it to prod if it passes. And if it fails at either point while you're trying to look at it, that's when you kind of send it back to the data science team and you say, hey guys, this is not it's not working as well as we'd hope, but at least now they have all the information that comes back that says, the accuracy has dropped by 4% or whatever it might be, along with all the logs and everything else, so they can try to troubleshoot it and replicate any issues that they might have. So, I mean, it gives a lot of confidence when we're, as new models are deployed, the confidence of success reduces the time spent by the team trying to kind of manually do all this deploy stuff. Kind of helps with this whole how do we get to prod, which is definitely a huge challenge for any size scale of organization. And then also the nice part about it is working with kind of like a lot of times it's not just the data science team working by itself, it's the data science team working with the data engineering team. So data scientists build the models and that kind of stuff, and they say, look, we need you guys to scale it. But once by those two teams working together, then you can get this like repeatable, tested and trusted pipeline for verification. So it's not just the one-off that happens, every time at the end of the sprint. And you're hoping that like this sprint, the end of this sprint is the same as the last one. And that's definitely a huge deal when you're trying to have consistent and better performance. So in summary, some of the lessons learned. So pull request testing is definitely kind of one of the best methods to ensure code quality. That's one of the reasons why that's where I kind of like have started and trying to make that integrated internally. We've seen that been helpful as well. As far as GitLab CI, I love GitLab. Don't get me wrong. I've used that for a lot of stuff internally. It's just if you only have a few GPU-enabled repos, it's probably good. It's just when you have something like on our side where we're like scaling out and we've got like tens to 100 of projects that need GPU CI, this is where Jenkins kind of comes in a little bit better, because then once you have the pipelines established and that kind of stuff, you can kind of parameterize and just kind of send the same code down the same Jenkins pipeline that will do all all those pairs of CUDA operating system driver and then even hardware versions that we want to be able to test without having to kind of go into each repo at for GitLab and kind of modify the YAML there, modify the YAML here, and copy and move all those changes. But I would also note that GitLab does have scale out on Kubernetes. So I mean, if you are kind of like mostly in the CPU world and only a few things, then GitLab works as well. So Kubernetes definitely is the key for like the broad testing, like across all those combinations that I mentioned. It's still definitely in development. As far as if you wanted to do it today and you wanted to be able to say, I need to be able to test 3 different drivers and 3 different types of hardware, then you can do it. You can do it with labels. It's going to be hacky, but it could work. You just have to make sure those nodes that are labeled for a particular driver version have that matching driver version. But at least the plugin has gotten better. In previous iterations, I want to say in version 1.8 of Kubernetes, not only did you have to like just say I need GPUs, you also had to pass in the paths of like where drivers were, and that gets like really messy, especially if you're trying to do multiple versions. So it's getting better. So as far as like kind of some like next steps, so continuing the plugin development and open source, I'll share some links at the end of where that will be deployed first. As far as like the internal stuff, we're continuing the rollout mostly based around Jenkins for GPU CI. Anything else that we're doing internally around like just general CI work is, frankly been around GitLab just because it makes it a little easier. And then as far as the next steps, kind of like what I said, going beyond CI, we want to start looking at how we can do some of the CD and performance testing stuff. Especially, I think one of the things that I really want to be able to do is make it a little easier for some of the partners that we work with, because we have a performance lab that does a lot of internal testing to say, hey, has this GPU database or whatever this code been able to successfully get faster as we do things. Right now, all those tests we kind of keep internally. We don't share that, but my vision and my hope, as long as legal will let me, is to actually go through and publicly expose what I can in that effort. That way, if somebody is going through and they have something that they want to submit, they can see all the public combinations of CUDA operating system, hardware, and stuff like that, versus and then we can hold back anything that's like pre-release on our side. Externally, GPU CI testing and that kind of stuff, as I was kind of demoing in my fork, that hopefully by next week or whatever, that'll be live, at least in the Go AI repositories. Anybody that went to Wes's talk yesterday, I know Wes, and we were talking about it at the Con Carne yesterday, and he's just like, please take this over. He's like, I don't want to do this anymore for Arrow, so that's also on the list. And then also improving the Kubernetes support in Jenkins and GitLab. So that way you're just not like pasting a code. So some of the research ideas, is there any way to kind of like integrate the GPU profiling and debugging tools to make things a little bit easier? And what I just mean by that is like, a lot of these CUDA tools are available, but as far as like capturing output and then being able to like throw it back over the wall, like if you run into a bug and you're trying to get us to help you fix it, it's a little bit of a manual process. Is there some way that we can make it like more like a click a button and run these tests? And then also maybe even Conda plus, or CUDA plus mini Conda Docker images, so I'm not having to bake my own. And then, like I mentioned before, defining like kind of a GPU CI standard stack, just kind of best practices around that, how we treat multiple Conda environments, multiple Docker files, and stuff like that when we want to scale out and do these pipelines. And then kind of like what I mentioned before with the profiling, is like easier bug reporting. That's one of the things that we've gotten feedback from talking about this 2 weeks ago at the GPU Technology Conference was, can you guys make it a little easier to report bugs to you? Like our stack might not match your stack. If we can get a little bit closer there and then maybe tarball things and move things back and forth, it'll definitely make things easier. And also welcome any other ideas that anyone has. So as far as like getting started, I just want to throw some links up here. So like I mentioned before, the NVIDIA Docker runtime, that is at the NVIDIA GitHub under the NVIDIA-Docker repo. The Kubernetes device plugin is under K8's device plugin. And then on my side, I will either fork or mirror whatever, depending on where legal says it has to go for the Jenkins plugins that I'm developing. There will be definitely at mine. And then for the Docker and NVIDIA runtime, if anyone's on Ubuntu and just doesn't feel like dealing with setting up NVIDIA Docker or Docker, and you just want to like run an Ansible script and copy like 2 blocks, it's up there and free to use. So with that, anyone have any questions?